Modeling of Poverty Eradication in Kedungkandang District, Malang City. Abstract poverty as worldwide problems has multi-dimensions, so that it is necessary a holistic approach to dealt with it. This research attempts to seek an appropriate strategy of poverty eradication by applying spatial regression analysis wherein value of water poverty index, WPI, put as dependent variable, travel time to senior high school and access to water, physical attribute and rate of participation, ROP, and density, social attributes put as independent variables with basic assumption that put it together development of physical and social aspects is a suitable approach on having better understanding of the poverty. This is an empirical research taken place at Kedungkandang District with unit of analysis of sub-district. Among 12 sub-districts general value of the WPI indicate high poverty level, except 2 sub-districts with medium and medium-low. Poverty in the district is mostly caused by use and environment components. Social network analysis with affiliation data of the head of households, measurement of ROP dan density indicate that social network in the community level through informal institutions form stronger social tie than their affiliation to formal institutions. Finally, classic test of regression model illustrates that both social and physical aspects give significant to the level of poverty. Strengthening social network through informal institutions and development of better access to safe water might decrease poverty level of the community. Keywords: components of water poverty, rate of participation, density, spatial regression analysis. Introduction. Poverty is a multidimensional and multi-sectoral problem that occurs in many countries in the world. The goal of poverty alleviation in 2030 has been mentioned in the SDGs goals. Poverty can be seen from several perspectives, so poverty also cannot be solved from one side only. In developing countries, the problem of low income, people living under the poverty line, is the main problem in economic development. As a result of this problem, many countries, especially Indonesia, has been created specific strategies to increase national income and poverty reduction. 1. Poverty in Indonesia is a problem that has to be seriously tackled in order to reduce the negative impacts of its poverty. Determination of the poor population can be categorized into 6 indicators such as livable homes, access to clean water and sanitation, income, ownership of assets, frequency of food and quality of food nutrition. 2. The number of poor populations in Indonesia, 2019, was about 9.41% and decreased by 0.41% in 2018. In general, residents in urban areas might say that they have better condition than the residents in rural areas, since the percentage of poor residents in urban areas are less than the rural areas, 6.695% and 12.85%, respectively. In addition, the poverty line in Indonesia was 425,250 IDR/capita/month 3. One problem of poverty is the limitation in basic needs, especially clean water needed. Water poverty or water crisis is also one indicator of poverty causes that are classified by the World Bank, 2010. Water poverty is limitation access of water needs for everyday community needs. People are classified to be in water crisis if the availability of water is not sufficient for their basic needs. Lack of ability to water access is one of problem of poverty in Indonesia. The problem of water poverty occurs due to population growth rapidly, so water use competition is getting severe. 4. Water Poverty Index, WPI, is a method that used to measure poverty in clean water covering 5 components, namely resources, access, capacity, use, and the environment. The WPI can be used for the government to build a strategy development in order to decrease poverty level in the scope community through clean water sector approach. 5. Sustainable Development Goals, SDGs, particularly in the pillar number 6. It is noted that to solve problem of water poverty that have target of ensuring the community in achieving universal access to clean water and sanitation in 2030. There are 4 ways to answer the goals or target of the SDGs. The first target is to achieve universal and equitable access to safe and affordable drinking water for all. The second is to improve the water quality by reducing pollution, reduce the rate of water loss, and minimizing the release of hazardous and chemicals materials, reducing half the proportion of untreated wastewater, and increasing water recycling, and reusing safe recycled goods globally. Thirdly, to improve the efficiency of water use in all sectors, and ensure sustainable use and supply of fresh water to overcome water scarcity, and reduce the number of people suffering from water scarcity. Then, the last is implemented integrated water resources management in all levels, including appropriate cross-border cooperation. 6. Households that have better community connection by participating in institution, have ability to manage their problems. 7. Good social interaction among society can assume that can be influence each other and exchange of information and knowledge. 8,9,10. Data from the Central Bureau of Statistics, 2019, shows that the poverty depth index in Malang City from 2018 to 2019 was unchanged at 0.55. The poverty depth index measured by average from gap of outcome each poor population and the poverty line. Coverage of piped water services with access from the local water company, PDAM, Malang City is about 96.24% of the total population of Malang City. 11. Kedungkandang District is one among 5 of the districts in Malang City, which located adjacent to area of Malang City. The number of poor people in the district is about 1,307 households. 12. Amongst all sub-districts in the district, in one side Kotalama has the highest number of poor households, meanwhile in the other side, Arjawanangan has the lowest 816 and 167 households, respectively. Hence, main aim of the research is to seek better understanding of the significant attributes of the poverty with basic assumption that appropriate poverty eradication strategy needs to put it together development of both physical and social aspects. 2. Data and method. A. Population and sampling. Research area is conducted in Kedungkandang District, Malang City, whereby unit of analysis is divided into poor and non-poor households. The sample size is distributed to 551 households of the total 38,463 households, 1.4%, spread across in 12 sub-districts proportionately. Data is collected through primary and secondary survey conducted from April, June 2019. B. Water Poverty Index, WPI. The WPI is a method to identify water poverty and measure the level of community welfare that is implemented in the level district. It has value in range between 0 to 100, consist of 5 components, namely I. Availability of resources, R. 2. Access, A. 3. Capacity, C. 4. Use, U. and V. Environment, E. The weight is applied to each component of the WPI structure, for the related region. The formula is the sum of weight times the value of each component, then divided by the sum of weights 13, 14, 15, 16. 1. Resources, R. Resources, R, is the physical availability of surface and groundwater. Water availability is calculated using the annual water availability approach per capita. Annual water availability is adopted from calculation of the water availability index, which can be searched by sum of groundwater availability and piped water, then divided by the number of population 16. 2. Access, A. Access, A, consists of 3 components that are counted, namely I. Access to clean water, percentage of households who have been served by safe water, 3. Access to clean sanitation, percentage of households who have bathroom or latrine, and 3. Access to septic tank individual ownership. Value of the component of access, A, is calculating by average value of access to clean water, access to sanitation and access to septic tank ownership 16. Access to clean water is the percentage of the population served by the clean water pipeline by PDAM, local water company. Access to sanitation ownership is a percentage of the population who have private latrine at home, while access to septic tank ownership is a percentage of the population who have private or communal septic tank. 3. Capacity, C. Component of capacity, C, consists of three components, covering I, level of public education, 2, level of public health, and 3, the level of income distribution. The level of income distribution is calculated using Gini index. 4. Use, U. Component of use, U, has two indicators, namely I, domestic, and 2, agricultural water use. Use of domestic water has a range that commonly used between 0 to 320 liters/capita/day. Use of water for agriculture is calculated by the percentage of land that uses irrigation then divided by total area of cultivation. 5. Environmental, E. Environmental, E, component has two indicators including water quality and open space area. The measurement of water quality includes piped water quality, PDAM, local company drinking water/HIPAM, community drinking water users association, and groundwater quality, well. For the open space area or vegetation cover is a percentage of green space area. The calculation of water quality in this research uses a laboratory test, then it is analyzed using STORIT method that has 5 parameters consist of pH, dew, turbidity, electrical conductivity, and salinity. The WPI value of each component is multiplied by the weight value. In this research using agricultural, industrial and social weights that classified from Sullivan et al., 2002, based on research area. The weight values are R equals 1, A equals 2, C equals 2, U equals 3, E equals 1. The final value of WPI classified into 5 level of poverty indexes, 0 to 47.9, severe, 48.0 to 55.9, high, 56.0 to 61.9, medium, 62.0 to 67.9, medium low, 68.0 to 100, low poverty index, 17. Meaning that the higher WPI index, the lower poverty level of a certain area. See social network analysis. Social network analysis, SNA, is an approach method to scrutinize relationship between actors and events as one set of affiliation data 11,16 that is run with a special software package for analysis of social network data, namely Uniset 6.666 for Windows. In addition, there is a special type of input data that is used for the SNA, namely affiliation data, that is a set of affiliation data that is developed from jointness of each actor/respondent into one or more institutions. There are 2 indexes that is used in the research to depict social tie among residents in the research area, explicitly rate of participant, ROP, and density 9. Result of the ROP describes level of participation of the community that is obtained from the average amount of community participation into a certain number of present institutions of the community area based on the formula that is designed by Wasserman and Faustatin. The density is calculated to find out how dense relationship among community members in the research area, meaning that the higher value of density might illustrate the more solid or higher tie between actors within the research area, that the formula is developed by Scott, Wasserman, and Faustatin. Then, the results of both indexes are divided into 3 classes, high, medium, and low classifications 9. 3 Result and discussion. A Water Poverty Index. 1. Resource, R. Based on observations survey of water sources, Kedungkandang District have 2 water resource from groundwater, and piped water connection. Access to water from groundwater comes from community private wells, meanwhile access to community piped water supplied by the HIPAM, Community Drinking Water Users Association. In general, access to piped water connection in Kedungkandang District is served by both the PDAM, Local Company Drinking Water, and HIPAM, Community Drinking Water Users Association, except Semarokandang Sub-District as the only one sub-district without access to piped water from the PDAM. The water resources, R, Value calculated by water contributions, water availability index, comparing with percentage of water estimation. The following table 2 describe results of the component resource, R. *A, surface water availability. B. Groundwater availability. C. Groundwater value. D. Piped water availability, M3/capita/year. E. Piped water VA. F. R value. Table 3 shows that the resource variable can be calculated by the value of water availability, which is divided into surface water availability, groundwater availability and piped water availability. For domestic use, community in Kedungkandang District has water source from groundwater through the building of private well, 8 to 15 meters depth, the PDAM services, as well as the HIPAM, Community Drinking Water Users Association, services. The availability of piped water is calculated from the availability of water in the reservoir. Availability of water for both poor and non-poor households within one village is considered to have similar value. The availability of surface water has value of 0 because in the research area, there is no household that uses surface water, lake water or river water, for their daily needs. 2. Access, A. All households in Kedungkandang District are served by clean water for their daily needs, but some people still use dug well as their access to clean water. Access to clean water is declared good, not poor, if every house uses piped water from the PDAM, local company drinking water, or the HIPAM, Community Drinking Water Users Association. Access to healthy waste is measured from the ownership of each household's septic tank, because with the existence of a septic tank it indicates that household have effort to treat domestic waste water. Primary data show that not all houses have their individual, private, septic tank, since some houses that have their own latrines, however the waste water goes to one communal septic tank in a certain public area. The following three tables, Table 3, 4, and V describe the value of component access, A, that is divided into combined of poor and non-poor households, poor and non-poor households. Table 3 illustrates general access of water in good value, 67 to 97. Table 4 and V indicate that access to water for non-poor households have better access than the poor one, due to their limited access to piped water connection and waste system. Kedungkandang Sub-District has 0% of water access because there is no piped access from the PDAM, local company drinking water, nor from the HIPAM, Community Drinking Water Users Association. Households in Kotalama Sub-District have low access to septic tank, due to their location of houses in the high-dense areas as well as along riverbanks. 3. Capacity, C. One of the WPI analysis components is the capacity, which includes level of health, education level, and expenditure distribution, which is analyzed using the Gini index. Results of the Gini index calculation for each sub-district is based on their income level. The level of education is calculated from the number of people who have a minimum education, senior high school, regarding the 2015 Minister of Education and Culture regulation that compulsory education for Indonesian citizen is 12 years. All respondents in Kedungkandang District have a good level of health. The following Table 6 displays value of the WPI of capacity, C, component in the district as the average value of health level, education level, and Gini index. The level of health in poor households tends to be the same as non-poor households, which means that there are residents in poor and non-poor households who are still sick due to clean water problems such as diarrhea. Calculating the level of education, poor households, the value of education is lower than the non-poor households, which means that members of the poor households who did not graduated from senior high school are higher than the non-poor households. Then, for the calculation of Gini index, the poor and non-poor households are considered having similar value, because the value of the Gini index is the index value for one region. The Gini index value is then equated to the WPI value by means of the one Gini index value multiplied by 100. 4. Use, U. Water use for people is the comparison between the standard water supply needs and domestic water needs. Water use for agriculture is comparison between irrigation area and total irrigation plus non-irrigation area. Not all villages have wet agricultural land and use irrigation water channels. There are areas that do not have agricultural land area due to limited data obtained. *A. Domestic water use, existing domestic water/domestic water demand. B. WPI value of domestic water. C. Agriculture area, HA. D. Irrigation agriculture and non-irrigation agriculture. E. Use of agriculture. F. WPI value of agriculture. G. WPI use, U. The calculation of variable water use, U, value in Kedungkandang District has the same value between the poor and non-poor households. The poor and non-poor households are assumed to have the similar domestic and agricultural water value, because they live at the same area. Agricultural land use is obtained from the total area of agricultural land. There are limited data availability to calculate agricultural land because of less detailed map of land use in the level of sub-district. As a result, there are only 3 sub-districts which categorized with low poverty level of the use, U, component, since the rest of sub-district have value below the 68th. 5. Environmental, E. The component of environment, E, has 2 subcomponents consist of vegetation cover and water quality. Vegetation cover is percentage of green space for each sub-district in the district. Measurement of water quality used the STORIT method based on the Minister of Environment Decree No. 115 of 2003 concerning guidelines for determination of water quality status. The value of water quality for each sub-district is assessed from the quality of physical and non-physical water quality. The physical water quality has seen from 3 parameters, smell, taste, and sediment. Whereas the non-physical variables were carried out by laboratory tests with parameters of pH, dew, turbidity, electric conductivity and salt content. The results of the calculation of clean water quality in Kedungkandang District are categorized as being mildly polluted, thus it is given a WPI value of 75. The environmental component implies an average value of water quality and vegetation cover. The value of water quality at each sub-district has similar value because water sample testing in all sub-district has a mildly polluted classification according to the decree of the Minister of Environment No. 115 of 2003. Water samples are taken in the form of water source supplied by the PDAM, the HIPAM, and groundwater, individual, private wells. Whereas for calculating the value of vegetation cover presentation, it is obtained the area of green space, public plus border plus cemetery, from the basic map of Malang City spatial planning. Table X indicates that there is only one sub-district which has low poverty environment index, namely Arjawanangan. Meanwhile, rest of the 11 sub-districts have poverty level from severe, medium-low. Though, the data is limited, still this is a very important thing to be noticed since it might contribute bad value of the whole WPI value. 6. Overall value of the Water Poverty Index. Table 11 indicates the total WPI value from the whole 5 components at each sub-district. There are only 2 sub-districts who have medium and medium-low WPI value, sub-district of Mergasano and Soegiarto with value of 62.7 and 73.7, respectively. In conclusion, Kedungkandang District has a serious problem of poverty level, in the point of view access to water. So that, one strong recommendation to eradicate poverty level in Kedungkandang District that it is very important to focus upon improvement and development of access to water, particularly regarding component of use, U, and environment, E, since they have good value of the other 3 components. Figure 1 shows the compilation of each component in each sub-district. The 2 components of resource, R, and access, A, have a fairly good value amongst others, meanwhile the environment, E, has the lowest value. The WPI radar might also be used as a reference for government development strategy on how dealing with poverty alleviation, which particular homework for each sub-district becomes very clear, as well as for the whole district. B. Social network analysts. 1. Rate of participation, ROP. The primary survey results show that Kedungkandang District has both informal and formal institutions. There are 5 formal institutions covering Sub-District Local Government Office, Integrated Healthcare Center, Posyandu, Family Welfare Empowerment, PKK, Sub-District Community Empowerment Agency, LPMK, and cooperatives. Meanwhile, there also exist 3 informal institutions in the level of community consist of male Islamic recitation, female Islamic recitation and Talal, pray together. Table 12, 17 depict ROP at each sub-district that is classified into poor and non-poor households, as well as the combination for both type of households. Comparison result of the ROP at Table 12 and 13 indicate that affiliation of the whole households into informal institution give higher level of participation. Though the number of formal institutions is higher than the informal institutions, but it seems that general community tends to join into a kind of informal institutions that is present in their neighborhood. Table 14 and 15 illustrate that for the poor households participate in the informal institution is also quite common for them. It might refer that access to link to a kind of formal institution is quite rare or far for them. Similar result for the non-poor households also occur that is showed from Table 16 and 17. Then, if we compare the ROP between the poor and non-poor households into formal institution in Table 14 and 16, it indicates that the value is quite similar in the range between low and medium. Meaning that access to participate into formal institution for the whole type of households is quite far or not popular among the community. From Table 15 and 16 similar pattern of the ROP between the poor and non-poor households is also found, though the value of ROP of the community to the informal institutions have higher value than to the formal one. In other words, informal institutions are more popular for the whole community regardless their economic background. 2. Density. Measurement of density in the community level might depict how dense relationship among of them within the sub-district. The following Table 18 and 19 depict the results of density divided into formal and informal institutions for the whole households, as well as the poor and non-poor households. It is shown that the density in Kedungkandang District has value from low to high classification. Through their affiliation into informal institutions, it gives exactly similar value of density for the 3 categories, the whole households, the poor households, and the non-poor households, that mostly in the level of medium, and only one level of high, occurred in Soegiarto sub-district. The next table depicts that the non-poor households have more variety of density in the range from low, medium, high, meanwhile for the poor households, majority sub-districts have medium level, except 2 sub-district with high value. If we compare value of the density between formal and formal institutions, it might conclude that relationships among community members is formed better through informal than formal institutions. The closer value to one or the higher value of density means that the relationships among households are very close to each other, and in the net draw it might able to form almost a close connection to the whole part of the community within the sub-district. In other words, informal institutions might have higher possibility to bring every community member into networks, so that in sense of flow of information or resources, connection among community members through information institutions might give more significant results than the other one. See spatial modeling. Spatial regression analysis functions to determine the spatial model between variables, as follows. Y. Water Poverty Index, WPI. X1, formal rate of participation. X2, informal rate of participation. X3, formal density. X4, informal density. X5, travel time to senior high school. X6, travel time access to clean water. 1. Analysis of Maranza and local indicator of spatial association, LISA. Box plot is a summary of data using box diagrams or graphically to describe the shape of data distribution and illustrate the presence or absence of outliers, data with extreme values. Fig 2. Box plot. In the figure 2 there are no outliers estimated for the variables carried out by the WPI value for each subdistrict for both lower and upper outliers. 2. Spatial weights. Spatial weights are a representation of the interlocation linkages that make a difference for each of the surrounding locations. This spatial weight is created applying GeoDAS software, with queen contiguity is to be chosen. The reason for using queen contiguity weights is because of the existence of areas that intersect with angles and sides in the study area, so that it will describe the best of the interlocation linkages. Fig.3 Connectivity map. 3. Lisa map. Lisa map uses to identify neighborhood based on the proximity of the measured variable. Lisa map illustrates the grouping of data based on the relationship between the WPI value and the influence of the nearest neighbor with the spatial weight of queen contiguity. Fig. 4. Lisa map. 4. Spatial regression. Spatial modeling is analysis using a classical model for the first steps as another determinant of spatial analysis. This classic analysis determines the use of spatial lag or spatial error analysis to form a spatial model. In the first classic test, there are several variables that must be discarded because they do not have the significance test, such as travel time to senior high school and informal density. Then, for further analysis, the value of formal rate of participation, informal rate of participation, density formal and access to water are analyzed. This research run classic model 2 times, table XX and table XXI, until all variables have a significant value of probability, 0.05. Table XX shows that time travel to senior high school has probability value 0.35, hence for the next classic test there are only 5 variables can be calculated. Tables XXII shows that spatial dependency diagnosis result have 5 coefficients. All coefficients have no significant value. Meaning hence, the final model that is formed for the research describes as follow. Y equals 20.39 plus 33.67 x1 plus 19.41 x2 22.13 x3 plus 14.81 x4 0.52 x6. Y. Water Poverty Index. X1. Formal rate of participation. X2. Informal rate of participation. X3. Formal density. X4. Informal density. X6. Travel time access water. The regression model displays that formal rate of participation, informal rate of participation, formal density, informal density, and travel time to access water variables affect the level of WPI. The rate of participation of both formal and informal institutions have positive value, meaning that higher the ROP of the community might form higher level of the WPI. Meanwhile, for coefficient of the density gives more interesting result, wherein in one hand, formal institutions give negative value to the WPI, and in the other hand, informal institutions give positive value of the WPI, similar to the ROP. It might assume that in order to develop community level, it is important to be able to control the negative effect of the formal institutions lower than the positive impact of the informal institutions. Then, the fifth significant independent variable is negative coefficient of the travel time to acquire clean water. This result is very clear, since the longer travel time to access water, the lower might occur to the WPI value. In other words, along with the SDGs target as well as the target of Indonesia universal access, it is very important to widen access to safe water through improved pipeline connection system. For conclusion, the WPI is a holistic method to measure poverty level through the 5 components, namely the availability of resources, R, access, A, capacity, C, use, U, and environment, E. It is suggested that in order to lower poverty level in Kedungkandang District there are at least 2 strategies need to be pointed out. Firstly, the 2 components of use, U, and environment, E, are important to be improved, wherein finding the best solution to solve conflict between water use for domestic and non-domestic needs. In addition, managing land use in best land use planning is also important to be tackled down, so that the rapid speed of the development might not give negative impact to the quantity and well as quality of the environment. Secondly, the note from the other three components is on how develop better strategy to increase access to safe water through widened pipeline water connection coverage service to reach the whole community at all distances. The two indexes of the social network analysis, SNA, rate of participation and density describe significant results on how community ties might give positive or negative impact to the development movement itself. Affiliation to both formal and informal presence institutions might give ability for both poor and non-poor households to be able to find better information or resources flow from both internal or even external sources of the community for their own betterment development. General suggestion might note that strengthening community ties through formal and informal institutions are necessary to established. Moreover, closer distance between formal institutions and the community member is important to be built in through better dissemination information as well resources within their formal program and activities based on the community-based participation. Interesting result occurs that both social and physical aspects give significant result to the effort on reducing poverty level in the community. Along with Goal 6 of the SDGs and national target of the universal access, improvement access to safe water for all through wider services of water pipeline connection is absolutely indispensable. Upmost of it, role of social network among community members in order to have symmetry information as well as resources sharing from both internal and external of the community might give better result of the achievement of the poverty eradication targets as a whole. 19. Acknowledgement. This research is funded by Indonesia Ministry of Research, Technology, and Higher Education. Sincere gratitude for the solid team, Anis Jalaratri. P. Bayusino Aji, Nadine Putri Wahyu, Nadyal Ilya.